All right, guess what this is? It is your last lecture for Calculus 1. Woot woot! Good job, guys. You did it. You've done a great job. So here we go. Last section is formulas for integrals of inverse trig functions, and this will look a lot like section 5-6. Going to give you some more formulas. I do not expect you to memorize these. These will be on a sheet of paper for you for the final. Okay, and again, du. We're using u because u substitution can be used at any time. Any function that's in that u spot will suffice as long as it's squared. Okay, just check these. My previous video I recorded, I wrote one down wrong. Had to start over, so checking it. Okay, cool. Also, as far as these are concerned, remember in just quick review of pre-calc, when we were doing inverse trig functions, like let's just take sine for example. The sine function looks like this. It's periodic, so it goes forever in each way. And when we started talking about the inverse sine, we said, okay, inverses flip themselves over this line y equals x. So the inverse sine kind of looks like this. Excuse my drawing, but this is, you get the idea. I'm not great at drawing these inverses. Okay, so the green is the inverse sine, and the problem is that the green is not a function. Okay, so what we did was we said, well, let's restrict the domain on this, and so we cut this off right here and right here. And so then we just define the inverse sine on this red part of the graph, and then you can notice that that red part of the graph is a function. We kind of we cut it off there as a convention. There's lots of other ways you could restrict the domain to make it a function, but you know, the universal math gods decided that's how we were going to do it, so that's what we did. And so that means that the domain for sine inverse, and also turns out tangent, they're defined the same. We define those in quadrant 1 and 4. And what that looks like is, if you recall, let's say we get an angle in here and as our solution, and this is 11 pi over 12. We said, hey, you have to actually, you can't call that 11 pi over 12, you have to call it negative pi over 6. And the reason is because I write quadrant 1 and 4 just to kind of be quick and clear, but what it technically is the domain is between negative pi over 2 and positive pi over 2, right? So that means that I can name any angle in this quadrant going this direction or this one going this direction. And if you want to look at that on a graph, what that means is this part of the graph here is 0, and this is pi over 2, and this is negative pi over 2. So the red part of my graph is in this range right here. If you call it 11 pi over 2, that's a value that's up here on the graph somewhere, right? Like 11 pi over 2 is higher up on the y-axis. And so that's the issue, is like we want to name it in this range right here. So instead of 11 pi over 2, we have to name it in a negative manner. Okay, I can talk to you more about that in class if you need more review on that concept. But also in terms of domain, we define cosine inverse in quadrant 1 and 2. And that's, there's no weirdness there with the negatives. You just name it like it is. So when you're pulling a cosine value off, you want to stay in, between here and here, between 0 and pi. All right, so let's do some problems and see how this is going to flesh out. We'll start shallow end of the pool. We got du over, or excuse me, I'm going to go dx over 9 minus x squared, square root over that. And remember, if you don't like that dx on top, this is the same thing. You can slide that dx to the side if that's more comfortable to you. And the idea is that you want to take your integrand and you want to kind of match it up to one of your formulas. So you want to say, what does this look like? And it looks like I've got a square root on the bottom. All these things are squared on the bottom. So I've got, if I want to rewrite this, I could say this is the square root of 3 squared minus x squared. So that looks like two things squared subtracted under a root. That's looking like sine, inverse sine formula. So then you just write what you've got. Okay, your function part, your inverse sine, your function part is your x. The number in the a spot is 3 in our case. And then I go plus c. And that's it. Okay. So try one of those. Pause the video real quickly. Example 5.50. You can try that. All right. Next example, we're going to do integral of dx over 25 plus 4x squared. So these are really contrived problems. I got 25 and 4 here. The reason is because I have to be able to write it as something squared. If I put 7 and 8 there, you couldn't do the problem. Okay, so they're really specific. And be careful how you write this. This is 2x quantity squared. Okay, so that's the whole function that's in that x spot. So because this isn't just x right here, we can use substitution. We can say, all right, let's let u equal 2x. Then that means that du dx is going to be 2. I can split up my du and my dx. Whoop. Trig function formula. So all I'm trying to do is match up this situation right here. I've got the 2x taken care of with the u. The dx here, that means I don't want that 2. That's too much. And so I'm going to multiply by 1/2 on each side. So now I can substitute in. The 1/2 I'm going to pull out in front. This becomes du. And I've got 5 squared plus u squared now. Okay, that's my 2x part. Whoop, right there. And my dx is there, substituting with the u and the 1/2 du. All right, and now what does this look like? I've got two things squared and they're added. There's no root. That looks like this guy to me. So it's going to be inverse tangent. So my first thing is going to be 1 over a, okay, and my a value is 5 in this case. All right, now don't forget this guy. I've got a 1/2 out here, okay. Then I've got the 1 over 5 from the formula, my inverse tangent, and it says that I'm going to take the inverse tangent of u over a. All right, so that's going to be u over a, in my case is 5, plus my c value. So this is going to be 1/10, and now you can substitute back in for u. So u was 2x, and that's your answer. Okay, So let's have you try one of those with a little, like just a small use substitution. Example 5.52. All right, and next problem, we're going to try, there are going to be some definite integrals in here too. And this is where that domain issue is going to come in. So we'll walk through this. All right, so again, we're trying to match this up. I want to write things as things squared. So dx over, this is going to be 2 squared plus x squared. Again, this is looking like tangent, okay, because it's got two things added and there's no square root. So the tangent, and this is just an x, so I don't need to use substitution in this problem. The tangent formula is 1 over a, so my a in this case is 2 times the inverse tangent of x over a, which is 2. Now in this case I don't need a plus c because I'm going to evaluate this from 0 to 2. So we're going to take the top value first and plug that in, 2 over 2, and then the bottom value 0 over 2. So I'm looking at 1/2 times the inverse tangent of 1 and 1/2 times the inverse tangent of 0. This is a good time to review what this means. And if you had me for pre-calc, I had you write out this sentence when we did it, and I think that's still a great idea if you're confused. When you have an inverse trig function, any inverse trig function, it says what it's asking for is what is the angle. Okay, it's looking for an angle whose y over x value is 1. That's what this question asks. Now, it's the y over x because it's the tangent. That's how this tangent is defined. If it was the sine, then you'd be looking for what's the angle where the y value is 1. If it was the cosine, you'd be looking for the angle where the x value is 1. So that means I need to go on the unit circle, and I'm taking all of my coordinates and taking y divided by x and trying to figure out where is that 1. Okay, so let's do that. Uh-oh. Did I lose my unit circle? I did. Okay. It's all right. We can draw out really quickly. So let's just look in quadrant 1. This point right here is root 3 over 2, 1/2. This point right here is root 2 over 2, root 2 over 2. And this point here is 1/2 root 3 over 2. Okay? So I want to take the y and divide it by the x. So right here, I'm going to get 1 over root 3. That's not it. Right here, y over x. Oh, root 2 over 2, root 2 over 2. This is going to give me 1. So this is where this is happening. And because it's a positive 1, I am in quadrant 1. If it was negative, it would be down here. Okay, remember tangent inverse, I'm only looking in quadrant 1. In quadrant 2, that's where the domain issue happens. So I realize that there is a positive 1 value over here. This coordinate right here, is also negative root 2 over 2 divided by negative root 2 over 2 is also a positive 1, but this angle right here is outside the domain because it's not in quadrant 1 and 4. So that's how this domain restriction works. So this angle name is pi over 4. So that's what I'm going to have. I'm going to have 1/2 times pi over 4 minus 1/2, and then now I want to know where is the angle where the y over x is 0. Well, that's zeros and ones always happen on the axes. So let's take a look at that. This coordinate right here is 1, 0. This is 0, 1, and this is 0, negative 1. So y over x, that gives you an undefined value. Y over x, undefined. Y over x, this is 0. So this angle name is 0. And again, it's also 2 pi, but that's outside of the domain. That's all the way around. So we want to use 0, and then you just simplify. So this is going to be pi over 8 minus 0. That's it. Okay. Again, if you need more practice with the unit circle, I'd be happy to help you in office hours. We can do some examples in class, but I am assuming that you are okay with that from pre-calc. You can try example 5.54 on your own to plug in some values and get some practice on the unit circle, and that's one that has the solution all written out for you, so you can follow along if you need extra practice with that. All right, great job today. I will see you in class.